So, good day, grade 8 Makati Science High School students, for our 7th lesson. So, this is going to be a two-parter series. We're going to briefly discuss the surface area. Okay, we're going to be briefly discussing the surface area of solid figures, okay, for our 7th module. There you go. Then, after that, we're also going to be discussing a lot of problems involving volume. Okay, so we're just going to have one problem for surface area, quite of a tricky problem, and then after that, let's go over the volume problems. Okay, so we have here this first one. Let's read the problem. So we have Protasio and Selena. Okay, Protasio and Selena plan to make a customized music box for their friend Lex for uh, their birthday. To do so, they will need to cut out square corners 3 inches by 3 inches from the rectangular pieces of the frame. It is then folded along the dashed lines that we have here. So the dashed lines are these blue lines that we have here. Okay, and shown below to form a box without the top. So it's kind of like you're creating a gift box without yet the top for this one. And if the volume of the box is equal to 162 squared inches cube, what is the dimension of the original frame before cutting out its corners? So for this one, essentially, even if it's asking for volume, we're trying to find out the area, the surface area of this flattened box. Okay, so let's say for example, we had the box. Okay, let's say for example, this is the box without a top cover, top cover. So therefore, the height of this box is gonna be 3, and its width is gonna be 2x minus 4 from this perspective, and then and then its uh its width is gonna be 3x minus 6 for this one. Okay, so for this one, why did it become 3x minus 6 when the entire length is equal to 3x? So it says here that this is 3. So what's 3 plus 3? Okay, so that's gonna give us 6, right, guys? So that's why this part here became 3x minus 6, because we subtracted the 6 units or the 6 inches from the top cover to get this part, which is 3x minus 6. And for this one, the entire length of this side is gonna be equal to 2x plus 2. And if this side is equal to 2x plus 2, and we know that this is 3 and this is 3, so if we add that, that's going to be equal to 6. And if we minus 6 from that one, so that's going to give us 2x minus 4. That is why the length of this side here is equal to 2x minus 4. Okay, so now that we have all of these cleared out, we know that this is the length, okay, and this is the width, or they can be interchangeable. And we know that the height of the flattened gift box for Lex's birthday is equal to 3 inches. So what formula can we create, guys, in order to find the value of x for this one and to know the original frame dimensions before cutting out its square corners? So how can we do that? Essentially, we're trying to find the value of 3x and then 3x minus 6, which is equal to the length, or more specifically, we're trying to find 3x. So this is the original length, and we're also trying to find the width, which is equal to 2x plus 2. So how can we find these two values? Okay, so we're given here that the volume of the square of this gift box is equal to 162 cubic inches. So what's the formula for finding the volume of a rectangular prism? So that's just equal to length times width times height. So that should give us 162. Okay, and we know that the length here after after subtracting 6 is gonna give us 3x minus 6, and the width here is gonna give us 2x minus 4, and we know that the height is going to be equal to 3, and all of that is equal to 162. So using the FOIL method, we can multiply this binomial, or the two terms that we have here. So what's 3x times 2x? That should give us 6x squared. And what's negative 6 times negative 4? That should give us positive 24. And then also, we have here negative 6 times 2x, so that's negative 12x. And negative 4 times negative 3, so that's also gonna give us negative 12x. So therefore, the center, or the term that's in the middle of this trinomial is 6x is negative 24x. So therefore, we have this trinomial 6x squared minus 24x plus 24, and then we have to multiply that by 3. Okay, so we have to multiply that by 3. That's going to give us 162. So all of that multiplied by 3. Or a much simpler method, we can divide both sides by 3. That's a much more simpler method, guys, because once we divide this by 3, this cancels out. So therefore, we have 6x squared minus 24x plus 24. That should give us 162 divided by 3. And what's 162 divided by 3? That's just 54. So now that we found the value of the volume, okay, the volume for our equation right now is going to be equal to 54 is equal to 6x squared plus 24x plus 24. We can transfer the 54 here to the other side. So that's going to give us 6x squared plus 24x plus 24 minus 54 is going to be equal to 0. And what's 24 minus 54? So that's gonna give us negative 30 is equal to 0. And from here, guys, we can factor this. Okay, we can factor this one. Now that we've had the 0 here, we can now factor it. So that's gonna give us 6 times x squared, okay, plus 4x minus 5, okay, is equal to 0. And from here, we can cancel this one. So this is going to give us x squared plus 4x minus 5. And therefore, the two values of our x's is going to be negative 5. Okay, it's going to give us, for this one, it's going to give us positive 5. Okay, positive 5 and then negative 1. Okay, so there you go. So how did we get positive 5 and negative 1? Okay, so what's negative 5 times negative 1? So that's negative 5. And what's positive 5 plus negative 1? It's going to give us 4. And therefore, we factored our trinomial perfectly for this one. So therefore, the value of x is just equal to 5 for this problem. Okay, so how did we get again the value of x? We used this formula. We transferred the 54 to the other side to get a 0. Then after getting a 0, okay, so there you go. We got these two values. And of course, we cannot use a negative value for this problem because this is all the values here are applied and therefore they are positive. So therefore, if x is equal to 5, we can now get the original width. The original width, which is equal to 3x. And we can now get the original length, which is equal to 2x plus 2. Now that we know that it's equal to 5, okay, so therefore the original, okay, there you go, let's use yellow. The original width is going to be equal to 3 times 5. So that's just going to be equal to 15 inches. And how about the length? The length is just going to be 2 times 5 plus 2. So that's going to give us 12 inches. And have we answered the problem? Let's check. What is the dimension of the original frame before cutting out its square corners? So we found the width, we found the length, and we also know the height is equal to 3. Let's see if all of this add up, and it should give us 162 as the volume. Okay, so for this problem, how do we know that our answer is correct? Now that we know that the original width is equal to 15 inches and the original length is equal to 12, we can minus 6 from both of these variables. And what's 15 minus 6? So that's equal to 9. And what's 12 minus 6? So that's equal to 6. Okay, and to get and to know whether you got the correct values for this one, 9 and 6 and 15 and 12. So this is before minusing 6 and this after minusing 6. So 9 inches and 6 inches. So what we're going to do is we have to get the volume. Okay, the volume should be equal to 162 and the length should be 6 and the width should be 9 and the height should be 3. So what's 6 times 9, guys? So that's equal to 54. And what's 54 times 3? If you multiply 54 and 3, you're gonna get indeed the volume, which is equal to 162 inches. And there you go. So therefore, we've proven that we got the original length of this figure, so it's equal to 15. The original width is equal to 15 inches. The original length is equal to 12 inches. And after subtracting the 3 inches height from the given figure on the cardboard that was flattened, so it became 9 inches, the width became 9 inches, and the length became 6 inches. And we got all of that thanks to the volume and also our knowledge about area on rectangles. Okay? And that's how we solve this problem.